How many people here are new to the IETF? Excellent, welcome. At the end of this tutorial, you're going to see a link for a survey. We are actively looking at how to improve the EduTeam materials and the tutorials, and we ask that if you take a few minutes to fill out that survey, that would be most appreciated. So today, to provide the InternetArea overview is Suresh Krishna from Ericsson. He is a long-time participant in the IETF. He has been the NomCom chair. He's currently working group chair of the InternetArea working group and the software working group. You will occasionally see him on Saturdays participating in the code sprint. And he's also worked on the diversity effort here at the IETF. So if you see him in the halls afterwards and you have any questions, he has a broad swath of experience in the IETF. And so at this point, I'm going to leave it to Suresh.
Thanks, Karen. So I don't know if you know the background of this overviews, but there's like several areas in the IETF, and every IETF we try to cover one of the areas. So this time is the turn of the internet area, okay? And so we had like tutorials for routing and security before, and if you look at the proceedings of the previous meetings, you can find those too. So if you want to get a brief introduction to the other areas. Okay. Next slide, Karen. So what I want to cover here today is like pretty much like the background of the internet area and what kind of work is being done here, okay? And some pointers for you to read. So if you want to get more into the internet area, what are the documents you need to start with, okay? So this is not going to be exhaustive. You're not going to get all the information out of it, but it'll give you an idea of what to expect in the area, okay? Next slide. So the internet area is like one of the 7 areas in the IETF. And so if you look at the numbers, like the numbers look like very much like 1/7, okay? So we have like 14% of the documents that are getting published. We have like 14% of the ADs almost. And so the working groups as well, like we're around like 1/7 of everything. So like we're kind of pulling our weight in the IETF. And internet area used to be much larger, like in the earlier days, but because of a lot of the reorgs, the art area has kind of become bigger. And we also like make it a point to close down working groups when they're done. So like working groups don't stick around for too long, but there are exceptions that I'll talk about. But that's something like we are very diligent in opening new things and closing like the old stuff. Okay. Next slide. So what you see there is like the core protocols of the internet area. So if you think of the OSI model, like if a lot of you might have studied this in school, right? Like it's not like very realistic in the world today, but we are in the layer 3 of the OSI model. So the network layer, and kind of looking more downwards on the internet layer and looking downwards, not as much upwards. Okay. And so IP like v4 and IPv6 are like the core protocols of this area, and along with DNS. So these things kind of are required for everything that connects to the internet. So we are kind of the basis for everything connecting to the internet. Okay. And we also have other protocols like DHCP, mobile IP, and NTP, which are also very, very critical. So DHCP kind of gives you configuration parameters, which are not your address and DNS servers. They all come from DHCP. So if you want to know what are your time servers or like where your proxy is, like you use something like DHCP. Okay. And mobile IP is stuff that's used for mobility. So when you have like phones or devices that move, so how do you keep connected with the same information, like connectivity information? So that comes out of mobile IP. So if you see a lot of these things have like v4 and v6 versions, and that's by design. So we don't want to mix configuration information or mobility information across versions. Okay, so IPv4 has been the very strong base on which the internet has been built, but it's not going to take us much far into the future. Okay, we're running out of addresses. There's a lot of hacks that we're doing. Like we have like NATs and bigger NATs. You have a NAT in your home, NAT in the provider's network, and so on. And it's making life very, very difficult for everybody. So like v6 is the way going forward. So if you go into sessions, you'll see like a lot of the stuff is focused on v6, and that's by design again. Okay. And NTP is like a protocol for time. So if your computer like shows the right time, most likely it's because of NTP. Okay, so like you're picking up the time from somewhere else, which has probably got a higher accuracy clock. Okay, so like NTP is a protocol that does it. Okay, so these are kind of the core protocols in the area. I'll give you pointers like for the RFCs to read about these things, so you can get like a brief overview of what you need to know before. Next slide. Next slide. Yeah. Okay. So what I've done is, I don't know if you can see clearly in the back. Do you see the text clearly or? Okay, good. So what I've done is like kind of done like a scatter of like the groups in the area. Okay, so this is like a very, very approximate grouping of working groups in the internet area. Okay, so this is like some working groups could be in one place or another, but this is like a idea of like where you want to concentrate on. Okay, so for example, if you want to look at the core stuff in the internet area, like the stuff about IP, DHCP, DNS, these are the working groups you need to pop into. Okay, or if you're interested in like mobility and multi-homing, you can look at the stuff in blue. Okay. The slides are available at the editing wiki, and there's a link at the end you can take a photo of if you want to look at the stuff afterwards. And so these are the kind of broad areas. So there's like core protocols, which have been going on for a bit. And there's mobility stuff, which is also ongoing for a bit. And there's also the low power stuff that's pretty new in the area. Okay, so what we're trying to do is build IP on top of a lot of the low power networks. So if you look at like a 6LoWPAN or like some sensor device, so we're trying to make them first-class citizens in IP world instead of putting them behind some proprietary protocol and having a gateway. Okay, so we are trying to do those kind of efforts in the internet area as well to make IP run on everything. Okay, and the time stuff is over there. It's kind of like isolated from the rest of the area, and so Karen will like fill us in on like what's happening on the time side. Okay, and there's also the transition work. So the transition work is kind of twofold. First thing is like, how do we get V6 into people's network? And following that, like, how do we get out V4? Okay, so how do we gracefully transition out V4 and go into a V6 only network or provide V4 services over V6? That's like a set of working groups too. Next slide. So that's one way of looking at stuff. Okay, so I'm talking about technology, right? So technology groups. And the second set of things, this is like very, very subjective. This is my view of like how I see the things. Okay, so people may disagree, even reasonable people. Okay, I want to put in like the faces of the working group. Okay, so like something on the left is something that's recently started up, which means that let's say you're new, like you probably have more things to do there rather than something that's shutting down. Okay, so when a working group is shutting down, they probably know like all the things they have to do, and they're probably like less open to new people coming in and bringing up newer ideas. Okay, so try to focus on the stuff on the left or in the middle, let's say for your first meeting. Okay, and the stuff on the right, you go in more for information. Like don't expect like people to be always looking for new ideas over there. So the stuff on the right is probably like winding down. So don't try to actually keep the right mind frame when you go to these things. Okay, so like the stuff on the left, like people are like more looking for new ideas. Stuff in the middle, it's like a mix of old ideas and new ideas and like maintenance and things like that. Stuff on the right, it's going to probably close down soon. Okay. Okay, so any questions till now? Like I'm going to go like a brief overview of each working group. So I'm not going to have much time to talk about each one. There's like 19 of them. So I want to take some questions now if you have questions. Okay, perfect. Oh, there is. Okay. So I'm going to get into that. So there's like a something called a data tracker, where we it's kind of the tools that we use for IETF itself, right? Like so we can find information about all the working groups and all the documents in the working groups. I'm going to cover that at the end of the presentation. Okay, and I think it's like a very good question that you asked, and there's a lot of information. It's very hard to find. And we've done like a really good job bringing this up, okay? Like, so maybe 10 years ago, things were much harder to find than today. If it's like, it's tough to believe, but it is. So I think like, I will cover it and then we can talk a bit more at the time. Okay, thanks, Sam. Okay. So 6LoW is one of the new working groups. So what I've done is like I've color coded like each working group, like to the kind of the area. So like it's kind of, you can correlate it with like low power or not. So 6LoW is doing work, which is developing the IPv6 stuff on link layers that are very constrained. Okay, so if you look at like a sensor, it runs like 802.15.4, which is like a low PAN. Any kind of optimizations for the IP protocols for those layers is getting done in this working group. Okay, so they have like a lot of relationships with other standard bodies who do this kind of link layers, because we don't do the link layers in the IETF. Okay, so we kind of liaise with them, we take their specifications, and we work according to their constraints. Because let's say, for example, there's like a link layer that doesn't support multicast very well, and IPv6 is like, does a lot of multicast. Okay, so something's got to change. So those kind of adaptations happen in a working group like this. Okay, so next slide. So 6-man is like kind of the maintenance working group for IPv6. Okay, so we had like an IPv6 working group for like the longest time. And at some point, we wanted to signal to the industry that kind of IPv6 is ready to go. Okay, so we don't want to keep working on enhancements all the time. So we said, okay, like IPv6 is like ready for deployment, and 6-man is like a maintenance working group for IPv6. So if we go to the field and there's like, we find issues there, and the issues come back using some other working group in the operations area. Okay, so people say like, oh, this stuff you did, it's completely broken, so fix it. So those kind of fixes, the maintenance fixes, the minor enhancements, they happen in 6-man for IPv6. Okay, so and it also does like, so the v6 is like a extensible protocol. So there's like options, there's like headers, extension headers. So those kind of things can be used in any working group in the IETF. And so 6-man gets the last say in whether those are approved or not. So the 6-man guys get to review like what the other working groups in the IETF are doing, extending v6. Yeah. Next slide. And 6-dish, this is also another low power working group. And so this is like a very, very simple time slotted thing. So there's no like, there's no exotic scheduling stuff here. Okay, everything is like on a time slotted. You just hop and everybody gets a time slot and they talk. Okay, so so this is like a technology developed in IEEE. It's one of the 15.4 variants, and 6-dish does the v6 on top of it. So they have right now a minimal profile for v6 to run on top of it. So that's what they do. Okay, so they are like tightly bound to one specific link layer. Okay, next slide. So this is like, I don't know if I'm like exactly right, but this is probably the oldest group in the IETF. Okay, so it was chartered like in 1991. So it's like 24 years old. So like we're not always good in closing working groups. Okay, so but there's like, when there's a lot of work to do, the working groups just stick around. And since DHCP is the protocol for delivering configuration information, there's always like new configuration information to give out. So like this working group doesn't die, because there's always like people who want to do stuff. Okay, so for example, right, like what we discovered right now is that for the transition mechanisms we talked about for v6, right, somebody needs to give the configuration information. That becomes DHCP. Okay, and if you looked at like what happened with the Snowden affair, right? Like, so there's like a lot of privacy stuff that's happening because there's government snooping on people and things like that. So we look at DHC and figure out like, okay, what's leaking? So when I look at a DHCP message you sent out, what can I know about you, right? So there was this instance of like the Canadian government, right? Like they were snooping on people at the airports. So they put up like access points and they look at like your MAC address and they could figure out where you're going, right? Like, so they know where you're flying from, where you're flying to. So there's like a lot of changes that have happened in the world, and like we're all reacting to this, right? Like, so this kind of pervasive monitoring, those kind of work is happening in all the groups. And we've done a really good job on the higher layers, right? Like, so like it's easier to defend HTTP information leakage. You put it in HTTPS and like people cannot see stuff, right? But on the lower layers, there's like a lot of stuff that leaks as well. Okay, so for example, if you take the default IPv6 address you all get, it's based on a MAC address wherever you go. So I could look at the last 64 bits of your address to figure out who you are, like across like time, across countries where you move. Okay, so stuff like that, we go ahead and keep fixing them as well. So next slide. And we've done quite a bit of mobility work in the IETF. Okay, so it's not been, I wouldn't call it very successful in the real world. Okay, so like a lot of the networks that you see, 3GPP networks, like the mobile phones, they don't use the IETF mobility protocol. So in that way, we kind of like not succeeded very well. But we still have quite a bit of deployment, like mainly in the Wi-Fi side. And like a lot of this work is kind of maintenance work. So we have protocols deployed, there's like issues that we find and small optimizations we can do. For example, we could, instead of sending everything to a home agent, right, like and sending the traffic out, we could try to take a more direct path. So those are the kind of optimizations we're working on in this DMM working group. And so DNSSD, so this is like kind of like a new effort that's happening. So bunch of you have Macs. So if you look at something like Bonjour, right? Like what it does is it's service discovery using multicast. Okay. So what it does is it's trying to discover stuff on your same link by doing a multicast message to figure out what else is in there. Except that it works only on your link. So if you're on a campus network or on an enterprise network, if you have a printer like one hop away, you're not going to be able to see it. Okay. So what happened is like a lot of people started like a grassroots petition to extend this across one link. Okay, so that kind of like came back to the IETF and to do like something that works across multiple links. So what we're trying to do is extend what we have as IETF specifications and make them work across like bigger links, how to make them more scalable, how to make them cross links. Okay, so that's what the DNSSD group is doing. And so the DNS privacy work, like I told you, right? It's kind of like there's a lot of this privacy work that's happening in the IETF that's direct result of the pervasive monitoring that's happening around the world. And so a DNS is like a very, very key protocol. So just by looking at your DNS request, right? Even if your traffic is encrypted, I could still figure out what you're looking at, right? Like, so I know you're going to some site you're not supposed to go to in some country, right? So there's like a lot of stuff we take for granted in some countries which are not available in other countries, right? Like, so censorship is like very, very prevalent in the world. And there is stuff that we can do as protocol designers to help people out in regimes where they don't have the same kind of freedoms like the internet provides, okay? So this is like something specifically targeted towards DNS privacy. Next slide. So HIP is a protocol that came out a while ago. It was like kind of like a grand unifying protocol. So like how do you make multi-homing work? How do you make mobility work? And one of the problems that was identified was IP kind of mix the locator and the identifier. Okay, so like your IP address is both who you are and where you are. Okay, so the idea was to split out those things, right? And HIP gave you like a cryptographic identity that you could carry with you wherever you go, along with binding it to your location. Okay, so this was like an experiment that happened, and I would say like it worked pretty reasonably well, right? Like so, but it doesn't have like the kind of deployment that's needed, but the experiment itself worked. So what people are trying to do is use the results of the experiment, so see what worked, what didn't work, and they're trying to upgrade it to standards. Okay, so this is kind of like more. So this is something you see in the IETF. So a lot of times when we're not sure how things are going to work in the real world, we send them out as experimental specifications. Okay, so if you look at an RFC, there's like a status for the RFC. So if you see experimental, it means that we don't really know like if it's going to work very well in the wild. Okay, so we send it out as an experiment, and see how it works out. So people bring back their experiences, and then it becomes a standard. Okay. So HomeNet is like a, yeah, go ahead.
Takeshi from NICT. Could you explain the difference between HIP and Lisp? It looks similar for me, so please.
Right. So so they're in the same class of solutions, right? So this identifier locator problem has been around, and there's like multiple solutions. Okay. So the HIP is like a solution that's been around like longest. It came before Lisp. Okay. So what IETF did is like we went to something, the IRTF. So IRTF and IETF are closely aligned. So the IRTF does the research work. So there was like a research group that was chartered. Okay, it was called the RRG, the Routing Research Group. And so Lisp was like one of the solutions that was discussed there. So all of them have the same idea, but how they do it is different. So the HIP is like a cryptographic thing. Lisp is more like a map and encap. So what you do is you map the identity into locator and you encapsulate to send the stuff over. And there's another protocol which was actually picked. It was called ILNP, so ID Locator Network Protocol, I think. So so there's like multiple solutions to this problem, and HIP is one of them. Lisp is another one. Thanks. So HomeNet is like kind of like a controversial working group. Okay, so when you go into this meeting, like don't be surprised that the people are like very excited. Okay. And this is generally true for IETF. There's a lot of working groups where you think people are fighting, but it's kind of how people talk. Okay, so like people are like very excited. They're like very passionate about what they do. So it's sometimes comes out as, it looks like fighting. Okay, so but like take it with like, I don't know, like abstract it out a little bit, because people strongly believe in their points of view. And this is one group where people strongly believe in their point of view, right? So the base idea of this working group is like you have a router in your home, right? Like everybody like who has an internet connection probably has a router, and it all works fine as long as there's like one link in the home. So you probably have like one flat link in the home. You have a router and everybody connects to it. So what happens if you have further links in your home? What if you have a router that connects to another router and it's got further links behind it, right? So how do you actually do the addressing for this? How do you make sure that when like wireless conditions change inside your home, how do you do the topology changes? How do you do the routing? So that's what like HomeNet is supposed to do. Okay, that's what they're working on. So the stuff that's controversial, like it's kind of getting resolved right now, is that like what routing protocol to use. Okay, so there's this protocol called Babel. It's like more used in like mesh networks and ad hoc networks, and ISIS, which is like more like an enterprise and internet kind of protocol. So those are the two protocols in the run, and people have been arguing forever about it. And finally, the chairs decided to break the tie and pick Babel. So the working group is going to be a bit more smoother in progress. Okay, so this is like very, very important, because you're all going to see this stuff in your home. Okay, so like a lot of the stuff we do, it's kind of sitting in a network somewhere. You don't always see like what is coming out, but this is like directly going to affect what you see in your home, what like your grandma sees in her home, right? And that's why we're trying to make this like simple, and there's like a lot of tough choices to be made here, and that's why you would see a lot of controversy here. Okay. So InternetArea is a working group that I chair, and so this is like kind of like an umbrella working group. Okay, so there's a few purposes of this. One of them is like a forum for people to discuss things. So there's a lot of issues that are common across multiple working groups, and there's no place to talk about it. So InternetArea is a place where if you have issues that are spanning working groups, you come and talk about it. Okay, and it also takes like orphan work, which means that there's like work that needs to get done, but there's not enough work to create a new working group, to do the administrative overhead of creating something, doing one thing and getting out. Okay, so like one-off items like also end up in the InternetArea working group. And another thing is like, this is how we interact with the other areas. So if there's other areas need to tell us something, or other SDOs, let's say the IEEE wants to tell us something, it comes through InternetArea. Okay, so it's kind of like an umbrella working group. We don't have like a very defined charter. There's like, if you look at like anything that probably has area in it, it doesn't look like a regular working group, because we don't have tight milestones. We don't have very restricted charter. Okay, so this is one of those groups. Next slide. So the LVIG working group is more, it is like not like a typical working group because they're not like really doing much protocol work, and they're more trying to see and talk to people who implement sensors, okay, and try to document the best practices on how do you do implementations of like IP on constrained devices. So they're trying to more figure out like what's in the field and putting it down as best practices for people to learn from. Okay, so this does identify some protocol flaws as well, but they don't fix them here. They had to go somewhere else to fix them. Next slide. So MIF is another a major effort, really. So this has never worked on the history of the internet. So if you have like two interfaces on your computer or your phone, right? All the phones, most of them have like two different interfaces. You never know what's going to happen. Okay, so you could get configuration information on one interface and use it on the other interface. So for example, right, you could use like a DNS server you got over Wi-Fi, and you could use it over the LTE link, and it's not going to work. But there's no separation of this information on the device. It's because like we haven't specified how do you separate the configuration information. So MIF is trying to define how do we handle configuration information in a consistent manner when you have multiple interfaces on the device. So this could be true, for example, if you have a VPN on your computer. Even with the one interface, you could have like a direct internet connection as well as a VPN. The only reason it works today is like the VPN probably cuts off all of the internet access, right? And that's probably why things manage to work, because you're only using one. But the idea is like we should be at least architecturally capable of handling multiple interfaces, and that's what this work is about. So NetX is like a working group which is about network-based mobility. And I'm not going to talk much about this because it's kind of winding down. So like we kind of finished all the work, like all the specifications are getting out, and it's probably going to get shut on pretty soon. Yeah. So for the time stuff, like I want to defer to Karen because like she's awesome. She knows much more about this than I do.
That's not a fair statement. So the Network Time Protocol Working Group has been around since roughly 2003. It was originally chartered to publish the NTP-v4 specification. NTP is one of the probably oldest and one of the more widely deployed protocols in the internet. Most people don't even realize it's there and they're using it. The current efforts that we're working on are maintenance of the NTP-v4 specification itself. There's a few odds and ends there, an extension header clarification that we're working on. An effort to replace AutoKey, which is currently an informational RFC for authentication of servers. And the network time security work is a suite of documents that's going to describe a replacement for that, which will be standards track. Documentation of best current practices. If you've been paying attention to the news and NTP recently, you've seen a number of issues associated with how NTP can be used, used is not quite the right word, but how it can be, it can cause issues on the internet. Most of the issues that it's causing are things that are known configuration issues. We need to do a better job of documenting how to operationally deploy it. And the final bullet there is one that I say with a little bit of hesitation. We're looking at a collection of requirements for next steps for NTP. We had talked a number of years ago about a new version of NTP. I don't know that that's necessarily where we want to go, but now is the time if you're interested in looking at the next steps for NTP to get involved in the conversation. Stay up. You're going to move to TikTok, aren't you? So the funny thing, if you noticed when Suresh did his slide earlier, he had sort of NTP as the ongoing work and he had TikTok as the closing down work, which seems a little bit odd because TikTok was chartered to look at next generation time synchronization protocols. And for those, there is a corollary standard called IEEE 1588, or the Precise Time Protocol, that started out from the instrumentation community. So people like originally envisioned as a standard for, say, connecting oscilloscopes together in a lab. And if you think of NTP, it was originally envisioned to connect computers together over the global internet, a wide area network 20 years ago. So each of these time synchronization protocols are, in essence, doing the same kind of thing, but they started from very different perspectives, and therefore their evolution has resulted in solutions that are very different in some ways. So the TikTok working group is currently, it has published a set of security requirements for time synchronization protocols. It's generic to both PTP and NTP. It's looking at an IEEE 1588 enterprise profile. And what that is looking at how do you operate 1588 over a wide area. It's looking at an experimental draft on 1588 over MPLS. Suresh mentioned earlier that sometimes in the IETF, if we have, we want to be able to get interoperability, we want to be able to do testing, but we're not really sure that we have the right solution for a standards track document. So what we do is we put it out there as an experimental, and then we hope that people will experiment with it and learn things and then come back when it's a little bit more mature to standardize it. So that's what the experimental draft in 1588 over MPLS is. We're also looking at some experimental multipath synchronization techniques. And finally, in cooperation with the IEEE 1588 community, we're working on their management aspects. So time is a little bit odd in the IETF because it's a very small community. And it's sort of a little bit of an isolated group that actually we try to, a lot of our key participants are people coming from other communities that are not, they're participating in the IETF primarily for time reasons and not necessarily for the broader internet work.
Thanks, Karen. So back to like the regular InternetArea stuff. No, just kidding. So like I want to talk a bit about the PCP. So like how many people have run like a gaming server or a BitTorrent client in your home? Okay, people out there. So what you have to do is like you need to go open up a port on your NAT, right? Because you don't get incoming connections otherwise. And this kind of worked okay because like, the box that you wanted to control was sitting in your home, right? Like the router was sitting right there. You just connect to it like SSH or Telnet or HTTP to it and you open up the port. Except that like in a lot of places in the world, this is not going to work anymore because you don't get an IP address anymore. Like a lot of places people get fractional IP addresses because there's another NAT box somewhere further up and maybe sometimes 2, sometimes 3. There's like people going through like 4 levels of NAT in some places in the world, right? And the problem becomes, so how do you actually run a service in your home, right? Like, so the current way of doing stuff like doesn't work. And there's like other cool protocols like UPnP, IGD, and things like that, which won't work either because they don't cross a link. So we needed something that will work across like your NATs without knowing how many there are. So like that's why we have a protocol called PCP, Port Control Protocol. So what you do is, when you want like a mapping to the outside world, you send like a packet saying, okay, this is what I'm trying to do. So I'm trying to open up a port for you or a set of ports from there. So, and this is kind of like NAT PMP that works on like a single link before. So like kind of you're expanding it to go beyond one link. And of course, this is all best effort, right? Your provider might tell you to go pound sand. But like the idea is like you at least have a capability of telling somebody upstream that you want this to happen. So that's what PCP is about. Again, it's like kind of the base work has been done. There's like a lot of extension stuff that's happening, but the base work is kind of complete. Okay, next slide. So Savvy is another thing that's like a very, very interesting concept. Okay, so it's kind of again winding down, but I want to talk a bit about it. So what has happened in V4 is that, let's say you get an IP address. So somebody could take your IP address on your link. Okay, they could steal your address by just sending like an ARP message saying like, okay, like this IP address is now sitting in some other MAC address, so then they can steal all your traffic. Okay, so what we want to do is like do something to secure the bindings between the IP addresses and the MAC addresses. This is like kind of unusual work that it does happen in IETF, but it's not like something that we typically do, like the lower layer stuff. But so that's what like the Savvy stuff focuses on. So you see like a switch. So the switch sees like a binding between an IP and a MAC address. When it changes, like somebody can settle by policy, like who wins. So there's like one policy which says first come, first serve, which means that you get an IP address, you keep it. If somebody tries to steal it, like the switch is going to reject it. Okay. And there's like stuff based on DHCP. So you snoop on the DHCP messages and do the bindings. There's stuff based on send, which is secure neighbor discovery. So what you do is your address is based on a public key that you're owner of. So somebody can prove that you own the address. So we can use that for finding the bindings too. So like all the work has almost been completed. There's like one document that's pending. The DHCP version is taking a long time to go through, but this again will be shut down soon. Okay. Next slide. So software, this is another group that I chair. So this is about like transition from V6, from V4 to V6, and how to provide continuing V4 service when V4 is actually getting turned off. Okay, so there's like two classes of solutions for this. Okay, and IETF did something strange, but kind of like process oriented for this. So there's like a set of encapsulation based solutions where you take an IPv4 packet, put it on a V6 packet, and send it off. Okay, then you tunnel it. And the second set of solutions were based on translation, which is like you translate like packet into a V6 packet, either by stuffing it a bit of bits, like 96 bits of whatever, to do the stuff, and like do mappings for the TOS fields and everything. So that work happened in the transport area in a group called Behave. So even though like a lot of the solutions were like closely allied, like so we had the translation-based solution go one place and encapsulation-based solution go to another place, even though they are solving the same problem. Okay, so software is the working group that like is mainly focused on the encapsulation-based solution, and so like the base protocols have all gone through the IESG, so we all have RFC numbers for everything. So there's like different ways of doing this, and we have solutions for all of them, which is not like a very good thing to do, but we have covered every aspect of this problem space to be certain, right? Like so. And so like now it's like mainly the surrounding work, which is the management stuff, like for what we did, the radio stuff, the authentication things, all those things are happening right now. But again, we are like kind of like going towards closure. We don't want to stick around for too long. Next slide. So Sunset 4. So this is like kind of like a futuristic working group, to put it in one way, right? Like so at some point we need to turn off V4. It's not going to happen very soon. Like we kind of been predicting this to happen for like a long time, and it's kind of clear the V4 is going to stick around for a bit. But what has changed now is like there's networks that are coming on that are V6 only. So there's a lot of mobile networks that are turning on V6 only, for either for lack of addressing space or for like reducing the management complexity. So if you have like two protocol stacks, you're going to have a more complex network, and that's clear. So some people are deciding to do V6 only. For example, like T-Mobile network in the US has like some sort of people who are V6 only. And IETF, if you want to try this for yourself, there's an IETF V6 only SSID, and you can try this all for yourself and see what all breaks. And as a spoiler, like Skype doesn't work. Okay, so that's probably, we've been saying the same thing for like 5 years, like, but Skype hasn't fixed it. So most of the stuff you know to work will continue working on V6 only. Okay, and there's some stuff that probably will take a lot of time to get fixed. So we need to figure out a way to turn off V4 gracefully. And Sunset 4 is kind of where the stuff happens. So let's say you go and ask for a V4 address in a network, okay, and the network doesn't have V4. It doesn't say anything. But what does the computer do? It asks again and again and again, forever. There's no way to tell your computer to stop. You cannot tell people that I don't have V4 here, go away, right? So that's the kind of mechanisms like this group will look at to figure out like how do you turn off V4. It's not as simple as we think, right? Like so, first case we say like, oh, just turn on V6 only, everything works. It doesn't, right? Like so, there's a lot of stuff we need to do, and that's what Sunset 4 will look at. So that's pretty much the summary of the working groups. Karen already talked about TikTok. So any questions here? Is it all clear? Can I ask questions now? Or? Okay, so I'll probably show you something that you can use to do things for yourself. You're probably going to forget everything I told you right now, but there's like a way to figure everything else back. Okay, so so this is like one thing I want to point out. This is pretty new. So there's like a internet directorate. So what we do is there's a bunch of people like who've been working in the int area for a bit, and the ADs have picked these people and put them into a team. So what we do is we review documents, like for either internet area documents or other area documents, but with the internet area hat on. So we look at like, does this do something funny with IP? Does it do something funny with DNS or DHCP? So those are the kind of things we look at, and we send comments. And this is like information we give to the area directors, and they follow up on it, like either put a discuss on, or they talk to the authors, figure out like how to fix it. Okay, so this is like a review team. And one of the goals we have is to figure out like, find out people who can get on this team. Okay, so we are looking for like people who are new to the IETF, who are like driven, like, and who like to read documents, like provide comments and things like that, and try to mentor them to get more into the area. Okay, so if you're interested in like doing this kind of work, like come to talk to one of us, like I'll show you where to look. So just come to talk to us. Okay, and one of the things we also do is like tutoring, right? So if you're new in a working group, you have some ideas, come talk to somebody, and we help you talk to the chairs, like see how to get your ideas presented, look at your slides, or look at your draft, those kind of things we do as well. Okay. Next slide. And this is like the, so we don't talk to all the areas equally. Okay, so there's like some areas we talk to more, some areas we talk to less. And I also put like a few touch points. Okay, so ops is like an area we talk to quite a bit. Okay, so, and that's because like our protocols get deployed in networks and operators have feedback. Okay, so let's say for IPv6, right, we did something and somebody says like, that's nuts, like you're crazy, this is never going to happen, and these are the reasons why. I put this on and my network went down, or like all the phones batteries died in 2 hours, stuff like that. Those are the things that come to v6 ops. And then what we do is like, yeah, this is a real problem, so we write down like operational solutions for it, and then we go back and fix the protocols in the internet area. So we have like quite a bit of interaction between, let's say, the v6 ops working group and the int area working groups. Okay. Similarly, like all the management stuff like happens in the ops area. So we interact quite a bit. We say like, okay, we want like some Yang expertise for this, so, or we want somebody to do a MIB review of this. Like we always go to the ops area. And routing is also closely aligned, like I talked about before for HomeNet. So if you want to pick a routing protocol, we don't have the expertise in the internet area. So we go to the routing people and say, okay, these are our requirements. This is what you're trying to do. So what do you recommend for us? Those kind of things happen in the routing area. And security kind of like interacts with everybody, right? Like, so the security people have to kind of sign off on everything, right? Like, so there's like a security considerations section in like every draft or RFC. And we need to identify all the threats to this thing and how we ameliorate the threats, right? So those kind of things, like we interact quite a bit with sec. And similarly, there's this DNS sec, like it's just security for DNS. Like we have like quite a bit of interaction on that. And also access control. So like how do you, for example, right, like we had something called PANA, which is like 802.1x, which provides some way of authenticating and authorizing somebody to get on a network. So those kind of things, we interact closely with the sec area. Next slide. Okay. So this is like something I don't want you to memorize, like just like you'll get the slide set. So if you want to start doing work in the int area, right, these are some documents that I think you should read. Okay, so like a lot of them are like, some of them are old, some of them are new, and like new ones doesn't mean it's like a new protocol, because we do quite a bit of updating of the protocols. Okay, so for example, right, like the if you look at the MIB v6 protocol, this is like a second version of the protocol. Okay, we always do revisions of our protocols based on feedback that we get. Like, so we implement the stuff and we put it on the internet and always update based on what we see. Okay, for example, right, 2460 is the IPv6 base specification, but it's been updated quite a bit. Like, so there's like a lot of issues that we found, and we updated, we wrote RFCs, and the RFCs have like a tag updating the base specification. Now there's work ongoing to fold all those changes in to make a new base IPv6 specification, okay? And that will replace this number over there. And so that's why like this is like a good starting point, but there's always like work that's ongoing to update our protocols. Okay, next slide. Okay, so like to answer you, right? Like, so this is like how you find information about like working groups, okay? So there's this thing called data tracker. This is like the kind of tools we use to handle IETF, both process stuff and technical stuff. So if you go to data tracker, IETF.org, like you'll see like a nice page. There's a lot of things in there. But if you want to find information about a specific working group, you put in like the working group and the working group name. Okay, so one of the names I showed you in the stuff, like it works for all the area working groups. Okay, so you find the name of a working group, you put this URL, put the name of the working group, you're going to see a bunch of information about that working group, which I'll cover in a bit. So if you want to see all the internet area working groups, you put #int. That'll give you all the internet working groups. So if you want to see transport working groups, you put #TSV, for example. So you're going to see like all the working groups in the IETF just by iterating through like a set of things. Okay, next slide. So this is how it looks like. I'm sure you cannot read what's in here, but I just want to point out like what kind of information is here. Okay, so if you put in the name of a working group, I just put in 6-man as an example, you're going to see like all the drafts that the working group is working on. Okay, so which is the working group drafts, like what the group has taken ownership of. It's not like a draft that you just wrote. Okay, so if the working group decides to work on it, it shows up on the top there. Okay, and if you scroll further below, you see all the RFCs that the group has published. Okay, so in order. Okay, so you can see everything that the group has ever done. Okay, and there's also like if you look on the top there, you see like a different tabs. There's like document, charter, and history, and so on, right? Like so you can click on each of those tabs. I'm not going to go through all of them, but you can do it in your spare time, right? It's not like rocket science. Okay, next slide. Okay, so like the charter tab is pretty important because the charter tells you what the working group wants to do. Okay, so and this is like one thing a lot of people don't see. So how a working group gets formed. Okay, so when a working group gets formed, so the area directors sit down and figure out the problem that the working group is going to work on, and they make it tractable. So it needs to be a small defined problem. So you cannot define a working group for world peace because it's kind of difficult to do and it's like not very defined, right? So the charter tells you, like, so if you scroll down a bit, you're going to see what the working group is supposed to do. So it's like text, it describes in English like what the working group is actually trying to do, and it's got milestones, like it talks about deliverables and everything. It's all in this page. Okay, and if you look at there, you're going to see the name of the chairs and the email addresses of the chairs. So if you want to contact them, you could like get in there. And there's also, it's not in the slides, but there's also like shortcuts for everybody's emails. Okay, so if you want to talk to the chairs of 6-man working group, you type 6man-chairs@ietf.org. It goes to the chairs. This is true for any working group as well. Okay, so you see the chairs, you see the area director, like for the working group, and you see the information about the mailing list. Okay, so if you want to start participating in a working group, the first thing to do is actually start reading the mailing list. Okay, which tells you what are the things people are working on, what are the discussions that are happening, so you don't waste other people's time or your time talking about something that's been talked about before. So let's say you have a question about something, check if it's been discussed before. Okay, or if you have an idea about something, check if it's been discussed before. So you spare yourself and everybody else the waste of time. Okay, so look at the mailing list and the archives, and that will help you quite a bit. And at the bottom, you see this Jabber chat, and this is how you remotely participate. So like everybody doesn't get to attend every IETF. So if you want to follow like a working group and you're not there physically, you go into the Jabber room at the time that's on the agenda, and you can follow the discussions over there. So there's like an audio stream you can listen to, and there's like a Jabber where you can actually type questions and get answers, kind of thing. Okay. So that's about it for me. So any questions? And I don't really want you to shoot me with arrows, but like I don't mind.
Arifin Matsumoto, thank you for a very informative talk. I found that especially the classification of each working group and the visualization of the based on the working group phase is very useful, especially for the newcomers and also for those who are not familiar with a specific area. So my question is that kind of information is available on somewhere in the IETF website and periodically updated?
So this is like very subjective, right? So this is something I did myself. So this is not like, I'm sure people will disagree on like where some specific working group needs to go, right? So I don't think this is official, but this is like something I wanted to help people to visualize the stuff, like just like you said. So I don't think this is like official. There's no like sub areas really. So, but these slides are available. So like to look at, okay. So, but there's no real official effort to do this classification.
Okay, so if then it may be better to gather such kind of overview talk somewhere in one place for newcomers website or something like that.
Yeah, if I can interject here, this is an excellent time to mention. Did you put the survey? Is the survey?
That's at the end.
Oh, okay. Oops. So part of what the there is an edu team, and it's looking at putting together the materials to help provide people better introductions. And Suresh's slides will be in the meeting materials for this meeting, but we're also looking at ways to generalize that material and keep it more up to date. And I haven't actually looked at the survey, but I'm guessing that there's going to be questions about that in the survey. So I would strongly encourage you to put your suggestions there.
Okay, thank you, Matsumoto-san.
Hi, I'm Kentaro Ibisawa. Very new for physically attending the meeting. I saw some working groups that does not plan for meeting for this IETF, but I saw that some of them is still active in mailing list. Does that not having meeting mean reflect the activity of the working group, or are there any other reasons not there?
So there's different conditions. So one of them could be like representing the activity, right? The second thing is like they're in a phase of work where they don't need the meeting done. So what has happened in the last few IETFs is that, so scheduling an IETF is a nightmare. Okay, so like when we chairs like request a meeting time, we specify a set of working groups we don't want to conflict against. Okay, so it becomes very hard to schedule a meeting because there's like everybody doesn't want to conflict with everybody else, right? So what the area directors did is like they said, like if you don't have pressing issues to meet, like we don't want you to request a slot. So scheduling becomes easier because we're already like 6 days of meeting, so we don't want to go even longer. So some people decided not to meet. And the other reason is like a lot of people are doing interim meetings, which is like virtual. So what people do is like they call for a meeting like 2 months before the IETF and 2 months after the IETF. So they don't meet here, but they're very active. So the right way to measure the activity is on the mailing list, like you already did. That's perfect. So somebody not meeting now doesn't really mean much. So take it with a grain of salt. If the mailing list is still active, the working group is still active.
Thank you.
Thank you. Thanks.
Just to interject again, also for some groups, in fact, we're trying to do this more with the time-related working groups. For some people who have a small area of overlap, developing remote participation and interim meetings makes a lot more sense to progress the work. So it's not just about the IETF, not about physically coming to the IETF to get work done.
Thank you very much. And can you go to the previous slide?
May I ask a very quick question?
Sorry. Yeah, go ahead.
You have done this presentation, which is really wonderful on internet. Is there other presentations like yours on the other groups as well, like security, et cetera, et cetera?
Absolutely, yeah. So like we take turns doing this overview. So the last one was routing, and the one before was security. So there's like few of them done already, but like I don't think all of them are done. So I don't think there's like a art area overview yet. But like I will. What I can do is I can put in like the URL for the stuff where you can find all the other things into the slides as well before the.
Perfect. Thank you very much.
Thanks a lot. Thanks. And so I want to thank like few people from the Edu team. Like they went through like my early slides and provided a lot of comments. So thanks, Karen, Miriam, Alice, and Brian and Scott. Like they've done quite a bit of review. So thank you very much for them. Like Karen is here, but the rest of them are not here. So thank you very much. And as the last thing, so you can find the slides at that location. But it's kind of like a chicken and egg, because if you don't have the slides, you don't know where it is. So if you want to take a photo, you can take a photo, or like Karen can figure out how to distribute it at some later point.
Right.
But they will be part of the IETF proceedings. So if you, at the end of this IETF, and you look at the proceedings, they're going to be there. Okay, so if you want to do it before, take the URL, you're going to find them there. And one of the things like you would ask of you like to do is like take the survey. It's going to really take a minute. I looked at it, it's going to take like 1 minute. Okay, if you don't think too much. So we would love to hear from you. So what worked, what didn't work, like please let us know. Okay, so thank you very much. Thanks for coming. Okay.